Hello folks, we're back again, and it is time for Unit 3's homework video 5. So let's just get started. This time we're going to talk about ratios. A ratio is a very fancy name for a fraction, so please don't let that name confuse you or that word confuse you. What's a ratio? A ratio is a fraction. Don't let it bother you. Let me show you what I mean. We have some candy in a jar. 5 sweets in a jar, 12 are yellow. Whoops, 5 sweets in a jar of 12 are yellow. We can write that ratio in different ways. We can say 5 are yellow out of a full amount, which is 12. So we can say 5 to 12. We can also write that as 5 to 12. To with the word in there, or we can say 5 to 12 and write it as a fraction. This is the preferred way. This is the way we're going to be looking at it. You will see the other two as well. If we have 3 flowers out of 12 in a garden are daffodils, then we can say 3 of 12. Now in this case, we would probably want to reduce and say, oh, well that's the same as 1 and 4. The ratio 3 over 12 is the same equivalent as 1 over 4. They are the same ratio. We could say 3 out of 4, or, sorry, we can say 3 out of 12, or we can say 1 out of 4. We can also write this as the ratio of 3 to 12, but again, we would probably say 1 to 4 instead of 3 to 12. And we can write it with a colon, so we can say it's 1 colon 4, or 1 to 4 is the ratio. Again, preferred way, we're going to write the reduced fraction for our ratios almost all the time. So every ratio, we've already said, has an equivalent fraction, and I think you have done a lot of work on trying to find equivalent fractions in your past, most likely. If I have the ratio 2/3 and I want to find equivalence to it, then I need to multiply the top and the bottom by some number that's the same number. And I can multiply it by a different number every time and do it an infinite number of times. That's my little infinity down here, because I can get an infinite number of ratios that are equivalent to 2/3. And I would do that by multiplying by 2 and getting 4/6. I can multiply by a half even and get 1 over 1.5. All of these ratios are equal. If I need to determine if a ratio is equal to 2/3, I would probably put it in a calculator. And if I put in 2/3, I'll get 0.66666 repeating. And then if I have A, B, C, D choices, I'd put them each in and see if I got 0.6. One of them I wouldn't. Same thing with 5/7. I would put that in my calculator, get a decimal equivalent to determine which are not equal. So things like if I have 5/7 and I multiply top and bottom times 2, then it would be equal to 2/14. If you have lots of fractions listed, then use your calculator and choose which one doesn't give you the same decimal. If they give you the same decimal, then they're equivalent ratios. If we have 2 ratios or 2 fractions equal to each other, then we have what we call a proportion. A proportion is just 2 fractions equal, and that's what you see in front of you, right? So there are tricky ways to solve it, or I should say there are tricks to solving. But I usually look at it just like I look at any other equation. I see a z, and I see it being divided by something. So how am I going to solve that? Well, I'm going to multiply both sides by 10. And I might look at it as 10 over 1. That would help me multiply because I have fractions here, right? So on this side of the equation, when I multiply by 10, I'll do it up a long way. I get z times 10 over 10, right? But that's silly to even do. I can reduce them right there and say, okay, all that's left there is z. Then on this side, I like to reduce first. I could multiply and get 140 and then divide it by 15, but I like to reduce first. 5 will go into 10 2 times. 5 will go into 3 times. Then I have 2 times 14 on top, which is 28, and I have a 3 on bottom. And z is 28/3, and I'm probably going to leave it just like that. I don't need to write it as a mixed number. I cannot reduce it because I've already reduced it. I want to point out a couple of things real quick. Actually, I'll point them out on the next slide. When I multiplied both sides by 2, so on that last slide, I saw 2 on a 10 on the bottom. And so I said, okay, let's multiply both sides by that to get rid of it, right? Be careful when you're multiplying, and recognize when you're multiplying and looking at one side and when you're looking at two sides. Maybe that sounded a little crazy. So let me just demonstrate for you. I see a 2 on the bottom, so I want to multiply both sides by 2. I'm going to set my 2 down and think about that multiplication. This is when I'm going, okay, well, here's my equal sign. I've already written that I'm doing something to both sides. Now I'm going to look at each side separately. And this is where I'm saying be careful when you're doing something to both sides and when you're just looking at one side. So right now I'm just multiplying 2 times 50 over 2, and I hope you see the 2's go away. And I have 50 is equal to, and again over here the 2's go away. And that was the whole idea, right? When I multiply both sides by 2, it gets rid of that 2. Now I have 3x equals 50, and I can divide by 3. And I don't see a simpler way to write that. I'm going to leave it as 50 over 3. Again, in algebra, we want to reduce our fraction, so we don't want it to be like times 2, 100 over 6. I wouldn't like that for an answer, even though it's equivalent to 50 over 3. I want my most reduced answer, but I don't want a mixed number. I want to leave it as that improper fraction, we would call it. We use improper fractions a lot in algebra. So what happens when the variable's on the bottom? Let's see if that mucks us up any. Well, I need to, again, I see 7 on the bottom, so I'm going to think about this as multiplying both sides by 7 first. If I put that over 1, it helps me out. And again, I'm thinking, okay, here's my equal sign. I want to kind of keep up with it and recognize that what I'm doing over here is saying 7 times 0.3. And that's going to give me 2.1, not 21, but 2.1. And I have to be careful that my variable is still on the bottom there, right? On the other side, my 7's go away, and I just have 5 left. Now I have this v on the bottom, and I need to get it off the bottom so that I can solve for it. So I think the easiest way is to multiply just like I would to get a 7 off the bottom. I'll multiply by v to get it off the bottom. So when I do that, it goes away on this side, and 2.1 equals 5 times v. My funny little v, isn't it? How do I get rid of v? I divide by 5, just like I would any other time. Now this time, I'm probably, since I have a decimal, going to need to put that in my calculator and say, what is 2.1 divided by 5? And I get 0.42. So funky answer, right? But I can, just to remind you, put that answer back inside here for this v, and I should get a true answer. So in other words, 0.3 divided by 0.42 should get me the same thing as when I go 5 divided by 7. And I'm going to need you to check that in your calculator, please. This guy looks a little funny, doesn't he? Let's tackle him the same way. We see this x plus 4 down here. And the way to make it go away, or I don't know what to say, go away, the way to make it so that I can solve for the variable, let's use those words, is to multiply both sides by that. And again, thinking about it being over 1. On this side, it just goes away, and all that's left is the 2. On the other side, we have to multiply the 3 through it. So think about that as a 3 right in front of that, right? On what's on the other side, but it's the same thing. So 3x plus 12 divided by 5. You still have a fraction, so we might think about getting the 5 to go away, and we do that by multiplying by it. Pretty straightforward, guys. When you see something on the bottom, you can multiply both sides by it, right? And every time it goes away. So what's that leave us with? 3x plus 12 equals 10. 2 times 5 is 10. And look, I have a simple two-step equation to solve. 3x equals negative 2. If I divide both sides by 3, I get x is equal to negative 2/3. Can I plug that in and check? Yes, I can plug that in and check. So quickly on this last one, nope. I do want to kind of show you a shortcut solving proportions, but also I don't want the shortcut to muck you up. So I'm a little bit weary. I will show you in just a second. Let's look at this guy. You're making a scale drawing of your house. If the scale is 3 inches to 8 feet. So basically they're saying, well, if this guy is 8 feet tall, then this guy is 3 inches right here. Making sense? So we're trying, or I guess right here, the height of the house. So they're telling us that the scale is for every 3 inches, there's 8 feet. And then they're saying, what number of inches will he use for a length of 88 feet? Well, if 3 inches is equal to 8 feet, I want to know how many inches is equal to 88 feet. That kind of makes sense? Make sure when I set these up, you can set them up in different ways. So somebody else might have come in and said, oh, well, it's 8 feet to 3 inches, which would be absolutely fine as long as when they came over here, they said that means 88 feet to how many inches. So see how I could flip them both, but I need to put feet both on top or feet both on bottom. So this is my equation I'm trying to solve for, and it's really 3/8 equals x over 88. I need to get rid of the bottom of my fractions, but actually I think I'll show you the shortcut this time. So here's the way I do the shortcut. When I have a proportion, a fraction equal to a fraction, it is the only time that I can do what you call cross multiplication, multiplying across the equal sign. So the kind of shortcut method, I think we already know, I was going to multiply both sides by 88, right? Well, the shortcut method, you know it's going to go way on this side. It always does. So 88 times 3 on this side, and then 8 times x on the other side. In other words, oops, I didn't put a dot in there, did I? In other words, that's the cross multiplying, and it will work to shorten up your multiplication and division that you have to do. So you can multiply top times bottom and set it equal to top times bottom, which is what I've done here. Then I need to divide both sides by 3, and look, I never even had to multiply. My x is not coming out right. Hang on a second. Something messed up. 3 times 88 and 8 times x. Whoops, that's what messed up. I knew something was up. So 8 times x gives me 8x. 88 times 3 gives me 88 times 3. I didn't even multiply it out. Divide both sides by what's in front of the variable. So divide both sides by 8. Then my 3's are not going away because I didn't have a 3 down there. So let's just divide normally. 8 goes into 88 11 times, and 11 times 3 is 33. So doing the shortcut method, x is equal to 33. That means if I have 88 feet in my real house, then I would have 33 inches in my drawing. One more that's a proportion that we're going to actually write when surveyed. 5 out of every 8 students like the food in the cafeteria. So 5 of them like it, and this is the number that were surveyed. The total number was 8. So we need to see if 60 people like the food, how many people were surveyed? So I simply want to find an equivalent ratio to 8/5, which has 60 on top and an x on bottom. No problem, I can cross multiply, and 5 times x will equal 60 times 8. And I'll go ahead and figure out what that is on my handy-dandy trusty nifty calculator. And I get 480. I'll divide both sides by 5. I find out that 96 people were surveyed if 60 of them liked the food. So in other words, what fraction is equivalent to 5/8 that has a 60 on top? It's 96 on bottom. It just kind of helps us fill in that equivalent fraction, and that guy was our answer. Lots and lots of ways to represent ratios and proportions. I hope you had fun playing around with them today and thinking of them in your real life. If you have questions about them, I will answer them in token. Have a lovely afternoon, and I'll